Okay, so now we're going to look at exponential derivatives, and I have the graph here of y is equal to e to the power of x, and this here is the slope of, or here's the tangent line, and so 2.48 over 1 is the actual slope of this tangent line at this value b. And so what I'm going to do is I'm going to go over to this scenario here, and I'm going to manipulate b, and let's see, here's my function, e to the x. As I change b, let us find where my derivative is. And what I see is that the derivative goes exactly on top of itself, which is quite interesting. And so what I can say is that the derivative of e to the x is just simply e to the x. And so that is the derivative. Let's try a couple examples. And so here we have, I want to find y prime. And here I recognize that there's a chain rule happening here. So I start with the outside function, which is e to the x, which is just itself, times the derivative of the inside function, which is 2x, is times 2. And so here is the derivative. Going to the next one, if I want to find the derivative, well, this is chain rule again. The 3 is going to come down. I write this function down as is, to the power of 2, times the inside function derivative. So I start taking the derivative of the inside, which is, when I look at this particular derivative, I get e to the minus x, which is itself, times, don't forget the inside derivative of this one, lots of chain rules going on here. So this is going to be times a negative 1, plus, and then the derivative of e to the x is just e to the x. And so if I tidy this up a little bit, I end up with 3 minus e to the negative x plus e to the x times e to the minus x plus e to the x to the power of 2. Okay, and now let's go to C part. We'll do this one in green and recognize that there is a product going on here. It's e to the minus 4x times the sine of x. And so if we remember the product rule, if I have y is equal to f times g, then the derivative is going to be f g prime plus g f prime. And so the order that you do this, and doesn't matter because it's adding, so I know I take the derivative of 1 times the original and vice versa. So if here is my function, I will take y prime, and we'll just start with, we'll write e to the negative 4x times the derivative of g, which is sine of x, that is going to be cosine of x, plus, now I'm going to do the derivative of e to the negative 4x, so when I do that, I go, the derivative of e is just e, times chain rule derivative of negative 4x is going to be negative 4, and then just times the sine of x. And so if I want to tidy this up a little bit, I can recognize that here is a common factor. So I can pull out an e to the minus 4x. And when I do that, I have a cosine of x minus 4 sine of x. And being able to factor that will often make further calculations easier. So there's your introduction to derivatives of e to the power of x.